Problem 913, write the following numbers in scientific notation. All right, so this isn't too bad. What we want to do first is, I personally like to copy the number down again, just so that I can show the decimal point moving. And in this number, 370 million, for part A, the decimal would be right here. So remember, we want to move that decimal until we have a leading digit that is greater than or equal to 1, but less than 10. So that means I'm going to be moving my decimal to the left. If I moved it to the right, then I'd just be making a larger and larger number each time. So I'm going to move my decimal until I have a leading digit that is greater or equal to 1, but less than 10. All right, I'm going to stop it there because it looks like I'll have a leading digit of 3.7. And in scientific notation, remember, you want to write that multiplication sign that looks like an X. And we know it's going to be multiplied by some power of 10. So far we have 3.7 times 10. Now, to determine the exponent, we need to figure out how many times we moved that decimal place. So I moved it 1, 2, 3, 4, 5, 6, 7, 8 places. So that is my exponent. And since I am moving it to the left, that is going to give me a positive exponent. Also, you can tell here that my original number in standard form here, it is not less than 1. So if you have the standard notation number that is greater than 1, then you're going to have a positive exponent. So this is what we have for A. Let's go ahead and take a look at part B now. Now, part B, I also want to copy this number down so I can move the decimal around however I want. So we have 0.00000000000. It looks like 11 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and then 76. Now, I'm going to go back and double check these zeros because if I even miscounted 1 0, I'm going to end up with the wrong answer at the end. So this is where precision is really important. So I'm going to go back and check. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yes, so I do have 11 zeros after my decimal point. All right, so now I've got to move my decimal in some direction where I find that leading digit that is greater than or equal to 1, but less than 10. If I move it to the left, I'm just going to end up with a smaller number each time I move it. So I need to move it to the right. And again, I want to move it until I see that I have a number that's greater than or equal to 1, less than 10. All right, looks like there it is. If I have 7.6, that fits the criterion. So 7.6 times, we want to make sure we're using that one that looks like an X. And we know it's going to be a power of 10. Now, to determine the exponent, I want to count how many times I moved my decimal. I did 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I moved 12 places. Now, is it going to be positive or negative? It's going to be a negative exponent because my original number that was in standard notation is less than 1. So if you have a number starting out that's less than 1, you're going to have a negative exponent. Or if you move the decimal to the right, it's going to be a negative exponent. So whichever way helps you remember better, stick with that. And this is our answer in scientific notation for part B. So that is all for problem 913.